So, hi guys, and I welcome you all to the very first lecture of machine learning. And I will be expressing this topic, and I will be talking about a lot of things. So, in very simple way, I will be explaining it to you. And yeah, let me know in the comment section how you feel about it, and what all things you like to learn, and what all changes should I make in my teaching aspect. Okay, so let's start off. So, what is machine learning? In a very basic sense, if I talk about what is machine learning, we basically, for example, consider this. Uh, Whenever I present a data to you, you basically try to interpret it, what the data is saying. For example, a human basically looks at the data, and with respect to this data, he tries to basically analyze what the data is trying to say, right? And with respect to this, when he analyzes the data, he makes assumptions that this will happen, that will happen, the sales will go up, down, etc., etc. If there is a holiday, was there a rise in the sales of clothing and things like that, in a very basic sense. So, in the same manner, we basically teach the machine as well. In place of this human, a machine comes up, or you can say, machine comes up where we just teach a machine to interpret the data and give us the results. And you know, it is basically a branch of AI, artificial intelligence, where we basically design algorithms in order to predict things, in order to get to know how to interpret the data, what all inputs are we putting, and what all outputs are we getting out of it. So this is a very basic, in a very basic sense, we can say that machine learning is all about training the machine to how it can interpret the data, how quickly it interprets data, and how well we are able to uh, 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 feed a proper data into it, so that when it becomes, when it goes into the prediction level, it predicts the right output for us, right? This is what machine learning is. So in a very basic sense, if I were to say, for example, uh, let's talk about the retail industry, for example. Now, in a retail industry, um, if I am a data analyst or any kind of an engineer, now I want to predict the sales of this particular product at a particular time or a month, whatever. How am I gonna predict it? So, in a very basic sense, if I talk about, a human being will first, what will he do? He will first gather the data. No, he will first, you know, make define a problem statement, that what are we trying to achieve, right? We basically further define the problem statement. So the problem statement is that we want to predict the sales of a particular product in this particular month, right? This is the problem statement. Now, after moving into the first part of it, this what will he do? What will be the next step? He will basically collect the data of previous sales, right? And what will he do? The next step would be, he would try to analyze the data. But before analyzing, he would first clean the data which needs to be analyzed, because there are a lot of what we can say empty rows into that data, or missing values, or any kind of unnecessary values that are present into the data. So the first thing that it will do is it will analyze, and he will first try to clean the data for the what we can say, for the data analysis process, right? So after cleaning and analyzing the data, he gets to find patterns in the data. After finding, he finds that whether that at this particular month, the there was a holiday in in this particular day, and the sales went up, you know and he could be like, he would basically use some of the formulas, basically the Excel or any kind of sheet or a tool, whatever he is using, or any kind of a coding language that he is using, in order to try to interpret how the sales is affected and why the sales is going up, etc. you know so in that sense, he makes assumptions, and when he determines the pattern and gets to know the assumptions, he comes to the result field, that due to this, we have rise in sales. you know so this is how a basic algorithm, or not algorithm, so this is how a basic process of machine learning works. Now, if we were to talk about in terms of machine learning, what engineer would do is basically, or any kind of a analyst would do is, they will basically first try to make define a problem statement, and then design an algorithm based on that particular problem. For example, the first step would be, what is the problem all about? Now, this is where the main picture comes up, because if the problem statement is not made very clear, you're gonna mislead a lot of things into the process. You might interpret the data in a very wrong way. So this is one of the basic things that is being asked with the interview questions as well, with respect to business analyst or any project management engineer who wants to get into the IT field and things like that. That the problem statement itself is one of the major things, that what are you to achieve, right? This is one of the basic things that it will first, that is what you want to define. Now, with respect to machine learning is using various aspects. If you're talking about you know image analysis, if you're talking about like NLP and sentiment analysis, everywhere, even like in retail sector, the thing I talked about in the previous example, it is used everywhere. Even like for example, in a very basic scenario, if you talk about, we want to predict the price of houses. So how will you predict the price of houses, if I were to ask you a very basic question? So a normal engineer or a normal analyst would, in a very human way, would say, give me the data for the houses, and he will first ask, like, address, you know address being one of the parameters, then square feet, then number of rooms, then Maybe it has facilities as well. And is it furnished, unfurnished? And on the basis of that, the value of property is basically determined. That, these are the factors, like, for example, the location defines that, the property rates at that particular location is like this with respect to the previous data. So the property rate is on a minimal something like this, and then the square feet is this. So, with respect to the square feet, the price is also determined. And with respect to number of rooms, for example, as you buy a 1 BHK flat, that costs a little low, that cost low, while as a 2 BHK flat costs you a minimal amount of money, whereas a 3 BHK flat costs you more money, and things like that. And like, does it have any kind of facilities like swimming pool, gym, etc.? And on the basis of that, the price of the house is predicted for that particular, company, or whatever you can designate. But this is how a very basic algorithm would work, right? In a web. Now, now, but the main scenario is it just about defining the problem statement? I don't think it is just about defining the problem statement. The problem statement is the first part of determining what all problem are we trying to solve, right? Which is obviously to some extent important. But after that, what would be the second process involved? The second process would involve data collection. You know, the data is collected from certain areas, and then it is like it is accumulated so that it is if the enough data is collected to make predictions. Then third point after that data collection data processing would be data processing. Okay. In the data processing step, what we do is the collected data is fed into the machine, or whatever you can say, system or database or whatever. And then it is basically the fourth step is data cleaning. Data is basically cleaned after processing the data, after loading it into various tools. For example, if you're using Python to analyze data, then obviously the data is processed into it first. And after that, data cleaning process occurs where you remove all the unnecessary values, outliers, and like I talked about null values and missing rows, missing values, and things like that. You perform all those steps. After performing all those steps, we give a basic step known as the EDA process. EDA process is something which is known as exploratory data analysis. Exploratory data analysis. Now, what happens in the exploratory data analysis? In the exploratory data analysis, what we all gonna do is basically, in a very basic sense, if I were to give an overview of what the data is all about, obviously, in the first sense itself, we know what problem are we solving, what data are we collecting, but how can I get to know that the data has this many rows, this much columns? What are the columns? How many rows? So exploratory data analysis is all about giving a basic info of how the data is, what all the data is all about. Uh, Even it involves designing or making visualizations like box plot. Is there any kind of an outlier? And if any of you guys don't know what an outlier is basically a term used to dedicate a particular condition, or whatever you can call a particular price point, or any kind of, like, not just price point, any kind of a factor that is totally different from the rest of the crowd. For example, if in a class a student has the highest marks of 99, whereas the rest of the students are around 78 on an average, and there are not many students who have scored, like maybe 2 to 3 students who have scored around 80, so the outlier is around 99, or maybe around, there are 2 to 3 students like 99, 94. So these are outliers because they performed totally different from the other students. They are totally different, totally unique. So these are outliers. So in order to find outliers, we basically construct a box plot in a very basic sense to define what are the outliers in that particular data set, right? We draw bar graphs. We also draw histograms as well for the same aspect in order to gain an insight of what the data is all about. So after performing the EDA process and data cleaning process, we move into the sixth stage, that is um, that is model defining. Oh no, we move we f- after performing the EDA, we create feature feature engineering. Now, what is feature engineering? For example, consider this, that in a data set there is certain column, or what you can designate, there is a certain feature that has not been that is not present, but you basically define it, or basically you, what you can say, you discover it. We can say we designate, no, designate it in that sense that you discovered a new feature, and that feature is determining a new opening a new scenario for that particular problem statement, right? So let's say that, hmm, I mean, if with respect to feature engineering, what can I say? Um, hmm, feature engineering. Okay, here we go. For example, consider this, that there is this particular brand known as Levi's, which sells shirts. Okay. And this shirt has a specific price point. And it what happens is there is a particular kind of a people buying that particular shirt. For example, there is load of guys who are well earning, who are high, who have high standards, and they are the maximal people buying those shirts. Okay. So a new feature can be created out of this, like who are these guys who are basically the people buying this particular kind of shirt, right? And in that sense, we get an insight about that this particular salary range kind of people are buying this particular shirt, right? So this is a new feature that has been created out of two features. It was not present in the data itself, but you created a new feature defining the way that, that this particular shirt and this particular at this particular price point, these are the people who are buying it. And there is a salary range also given, and these are the salary, here is the salary range given for them, and these are the people who have this amount of salary. This is the minimum threshold for the salary, and this is the maximum threshold for the salary. So in our data, we get to know that this is the minimum salary where these kind of shirts are bought. So this is a new feature that has been created out of you, right? So after creating new features, what we do is we train it in the model. We try to fit into different kinds of model based on different problems, based on different factors, based on different scenarios. For example, there could be a different algorithm for image recognition, right? There could be a different algorithm for predicting stock. There could be a different algorithm designed for NLP as well. So there are different ways in which we designate a model. After training the model, what we do is we try to evaluate whether the model is working or not. And is it making the predictions very well or not? Is it making the right predictions or not? That is what we try to evaluate in this process. And after evaluate, what we do is we deploy it. We deploy it into the real model process, and we still look at it. Businesses keep looking at new and new things, and they keep rectifying their errors, and they keep doing it in order to be updated in the market, that how is their algorithm performing. So this is the basic of how what machine learning is, and I hope that you guys are able to understand what machine learning is. So in the next video, I will be talking about types of machine learning, uh, types of machine learning, and how different algorithms work. What is linear regression? What is logistic regression? We are gonna talk about gradient descent and things like that. So wishing you all the very best.